Welcome viewers, in this video we will see the solved problem based on the DC transient response of RL circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic DC transient response of RL circuit, solved problem 3. Now refer the circuit diagram. So this is a circuit diagram available. Two voltage sources, 50 voltage and 10 voltage, is connected by the switches there. Position 1, position 2. It is connected with RL circuit, resistance and inductance, 5 ohm and 2 Henry. So the statement is, in the circuit, switch S is in position 1 for a long time and brought to position 2 at t equal to 0. Determine the circuit current. So there are two positions available. In position 1, the switch is kept for long time, so that inductor will store the energy. After that, the switch is positioned at position 2 at t equal to 0. For that, we need to determine the circuit current. What is the current flowing through the circuit? Now we'll see the, after closing the switch to the position 2, we can apply the Kirchhoff's voltage law to get the equation. We can apply Kirchhoff's voltage law, KVL, after closing the position 2. So after position 2, closing the position 2, what happened? This is a voltage source, 10 voltage. The circuit elements are resistor and inductor. So the voltage source is equal to voltage drop across resistor and inductor. That is the Kirchhoff's voltage law. Voltage rise equal to voltage drop. Voltage rise is 10 voltage. Voltage drop is voltage drop across resistor and inductor. So based on that, we can write this equation. The current flowing through the circuit is I. So 10 voltage equal to voltage drop across resistor, V equal to I into R. R is 5 ohm, I is current I, 5I. And the drop across inductor is 2 di by dt, that is equal to 10. So equation number 1. So we are applying Kirchhoff's voltage law, that is equal to voltage rise equal to voltage drop across resistor and inductor. Now we can take the Laplace transformation on both the sides in order to convert the t domain into s domain. So taking Laplace transform on both the sides. So 5i is nothing but 5i of s plus 2 into di by dt. Laplace transform of di by dt is s into I of s. Laplace transform of differentiation is s into I of s. Integral means I of s divided by s minus initial current. I0 plus is nothing but the initial current. We need to subtract the initial charge, initial current or initial charge. That is equal to 10 divided by s. Differentiate Laplace transform of constant is 1 by s. So it is 10 by s. Now we'll see what is this I0 plus. We need to subtract the initial current. Now we'll see what is the I0 plus current. I0 plus is the current passing through the circuit just after the circuit switch is in position 2. After changing the position from 1 to 2, the current flowing through the circuit. Since the inductor does not allow sudden change in current, so this current is equal to steady state current when the switch was in position 1. While changing from position 1 to 2, the current flow is the I0 plus, but the inductor will not allow sudden change in current. Slowly it will increase or decrease. So this current is nothing but the current when the switch is at position 1, because the switch was in position 1 for long time. So the current flowing during the position 1 is same as the position 2. Now we'll find the current when it is in the position 1. I0 plus equal to V by R. V is 50 voltage. At position 1 is connected to 50 voltage, position to 10 voltage, divided by resistor value 5. So it is 10 ampere. So I0 plus value is 10 ampere. So this current is nothing but current flowing during the position, which is kept at position 1, that is same as position 2, because inductor does not allow sudden change in current. Now we can substitute this value I0 plus equal to 10 ampere in the equation 2. In this we can substitute. So substitute 3 in equation 2. Substitute the current value in equation 2. So 5 I of s plus 2 into s into I of s minus I0 plus equal to 10 by s. This is the equation 2. Here we need to substitute I0 plus equal to 10. Right? So multiply inside now. 5 I of s plus 2 s I of s minus 2 into 10, 20 equal to 10 divided by s. Now I will bring this 10 minus 20 that side. So it become plus 20. Now here take the I of s common. So it is 5 plus 2 I of 2 into s equal to, here take the s common. So that s is available here. So 10 plus, here s is not there. So it is multiplied 20s. 10 plus 20 s divided by s. Right. So that from that we can find the I of s value. Bring this term in the denominator. 10 plus 20s divided by s into 5 plus 2s. Right. Now we need to take the inverse Laplace of this equation so that we can determine the circuit current. So while taking inverse Laplace, we can get the again t domain. Initially t domain converted into s domain by Laplace transform. Again s domain converted into t domain by inverse Laplace. But we cannot take the inverse Laplace directly here. It should be in the particular format. Then only we can take the inverse Laplace. So that this equation can be written by using the partial fraction technique. We need to split like this. So that this time we can easily take the inverse Laplace. This time we can easily take the inverse Laplace. Right? So 10 plus 20s divided by s into 5 plus 2s equal to, certain formulas are available, certain formats are available. Accordingly, it is written as a by s plus b divided by 2s plus 5. These two terms are splitted. A by s plus b by 2s plus 5. Now take this term common. Here already this term is available. Now we will take the LCM. S into 2s plus 5. Here s is available. So we multiply with 2s plus 5. Here 2s plus 5 is available. So multiply by s. Right? Now it is we will take the LCM. Now it is becoming a single term. So these two terms are cancelled. This term is cancelled on both the sides. So what we have finally, 10 plus 20s equal to a into 2s plus 5 plus b into s. Right. Now finally we got the simplified expression. Next our aim is to find the value of a and b, so that we can go for inverse Laplace. How to find the a and b value? From this value itself we can identify. If you substitute s equal to 0, this term is 0, so that we can find a value. Similarly, if you substitute 2s plus 5 equal to 0, so that s equal to minus 5 by 2. If you substitute minus 5 by 2 here, this term got 0, so that we can find b value. So based on that, first we will substitute s equal to 0. S equal to 0 is substituted here. So 10 plus 20 into 0 plus a of 2 into 0 plus 5 plus b into 0. Right? So this s is substituted as 0. 10 plus 20 into 0 plus a into 2 into 0 plus 5 plus b into 0. Right? So this term is 0, only 10 is available. This term also 0, this term also 0, only 5 is available. A5. 5 is A5 means 5a. 10 equal to 5a, so a equal to 10 by 5 is a equal to 2. Right? By substituting s equal to 0, this term is becomes 0, so that we are easily calculate the value of a equal to 2. Similarly, in order to eliminate this value, we are going to substitute s equal to minus 5 by 2. Right? So 10 plus 20 into s is minus 5 by 2 equal to a of 2 into s is minus 5 by 2 plus 5 plus b into s is minus 5 by 2. Right? So 10 minus, here minus is there, minus, here 20 divided by 2, 10. 10 into 5, 50. Right? See, this 2 got cancelled, minus 5. Here plus 5. So totally this term become 0. Here minus 5p by 2. Right? So 10 minus 50 equal to minus of 5b by 2. Now we can go for the further simplification. So 10 minus 50 minus 40 equal to minus 5b by 2. So minus minus got cancelled. So b is nothing but multiply this 40 into 2 divided by 5. This 2 is brought into numerator, 5 is brought into denominator. So 40 into 2 divided by 5. So this 5 goes 8 times. So 8 into 2, 16. So B value is, now we got 16. Right? Now we calculated the A and B value that we can substitute in this equation number 4. So I of s equal to A by s plus B divided by 2s plus 5. Now A is calculated as 2 by s plus B is 15, 16 divided by 2s plus 5. So that is equal to 2 by s plus 16. We can take this 2 outside. We need to bring in the s format, s plus, so that this 2 is taken outside. So s plus 5. Here the 2 is not there, so 5 by 2. Right? So it is in the format s plus a. S plus a. Here 2s is there, so that we have to take the 2 outside. It is in the standard format. Now we can easily take the inverse Laplace on the both the side. So 2 by s is nothing but 2. Right? Already the 10, the inverse Laplace of 10 is 10 by s. The inverse Laplace of 2 by s is 2 plus 16 by 2 is there. 1 divided by s plus a. Here the formula is there. 1 divided by s plus a is e power minus at. So based on that, 1 divided by s plus 5 by 2 is e power minus 5 by 2. Here plus mean here minus. Here plus mean minus. Here minus mean plus. Right? So based on that, this 1 divided by s plus 5 by 2 is written as e power minus 5 by 2. 16 by 2 is already available, constant. So 2 plus 16 by 2 is 8. E power 5 by 2 is minus 2.5 t. So this is the final circuit current in terms of t. 2 plus 8 e power minus 2.5 t. Right? In order to bring this term s plus a, we are taking this 2 outside. Right? So by comparing these two, we can easily write this. So in this video, we discussed the solved problem based on the RL circuit, DC transient response of RL circuit. We calculated the circuit current I of t in terms of the current, in terms of the time we calculated by taking the inverse Laplace. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.